So okay, we're in the process of trying to work out how will this new random variable x1 plus x2 all the way up to plus xn, how will this be distributed? Well, firstly, it can take on values between 0 and n. So 0, 1, 2, all the way up to n is the maximum value it can take on. And we want to know what is the probability that you get n. Well, the probability that you get I. What is the probability that this new random variable, what should we call it, z, let's call it z, in fact let's call it s for sum, the probability that s is equal to I. So what is that probability? Well, okay, if you get, remember that all of these ones can equal 0 or 1. So if s is overall equal to I, then I of them had to be 1, and n minus I of them had to be equal to 0. So you had in this sum, you had 1 plus 1 plus 1, you had I lots of them, and you had 0, 0, 0, 0, plus all of those, and you had n minus I of those. And okay, so each one of these has to either take on a 1 or a 0. So how many different ways are there of getting I 1s and n minus I 0s when you've got these n different things that can take on 0 or 1? All we know is that I of these have to be 1 and n minus I have to be 0. But is x1 going to be 1 or 0? How many different ways are there of, I don't know what the right word is. We're asking for, basically we're asking for how many ways are there of rearranging this, where for instance 0 plus 1 plus 1 plus 1 plus 1 plus, let's put the 1 there, plus 0 plus 0 plus 0 is a different combination of this, because you know this, in this one x1 was equal to 1 and in this one x1 was equal to 0. So these are different basically. We want the number of ways of rearranging these things amongst themselves. And we know from combinatorics that that is n choose I. So n choose I is the number of ways of rewriting these 1s or 0s. Basically, it's the number of ways of designating the I1s to these n things, and then designating the 0s to the rest of them, basically. So it's the number of ways of picking n things from here to bear the title I will be 1. Okay, and then what we want is, so that's the number of ways of doing that, and then what we want to multiply that by is the probability that that event actually happens. So that's the total number of these combinations. So once you've actually fixed a combination, so fix a combination now and consider it. So for instance, this combination, what was the actual probability that that combination actually happened? Because yes, okay, we're summing up we're summing up how many of them we overall in total have, but we need to know what the probability of an individual one was, and that's the importance that they are independent and identically distributed, so that the probability of each one, i.e. the probability of this one and the probability of this one, are the same. So now what we want to know is what is the probability of a single combination like that happening. Well, it's the probability that you got I1s times the probability that you got n minus I 0s. Well, the probability that you got I1s was the probability that this one is equal to 1, so let's say x1 was equal to 1, intersect the probability that x2 was equal to 1, intersect the probability that x3 was equal to 1, intersect all the way up to the probability that I was equal to 1, xi was equal to 1. But of course, those could be, you know, you could rearrange them, so it doesn't have to be x1 through xi that got the 1s, but that's taken account of in here. And we know because they're independent that that's equal to the probability that x1 is equal to 1 times the probability that x2 is equal to 1 times the probability that xi is equal to 1, etc. So you get I lots of p to the, times itself, so p to the I, and then the same here, but the probability of that is q, so you get q to the n minus I. So we find basically that this sum, this function of random variables, this sum of random variables, it has a distribution as well, and that distribution is going to be the binomial distribution, which makes sense because this sum is counting the number of heads you get, therefore it should be distributed in the binomial sense, which we've seen already.